relationships. So we're going to be looking at something called indirect measurement. Okay, so indirect measurement is used when you can't do direct measurement. Can you come to school with your own paper? That would be great. Okay. Why don't you stay after class and have a discussion with me, okay? All right. So normally if you want to find the measurement of something, you just get out your tape measure and you go and you measure it. But what if it's the flagpole in the middle of the lower quad right here? Can anybody get the height of that flagpole over there? A ladder? Like, okay, what if you don't have a ladder?
No, I'm on one of those electric things that goes up.
Oh, yeah, the electric ones, but it's sort of like a ladder. Yeah, an electric ladder. Okay. Anybody else have a way to get the height of that flagpole up over there? All right. Estimating it.
Use that iPhone. You know the one that like.
Oh, yeah. Your iPhone app. Okay, cool. All right. It's not exact, but it's approximate. Okay. So for example number 1, we're going to use the flagpole. But over to the left here, we're going to draw a sun. Okay? Because the sun is going to do something with that flagpole. It's going to cast a shadow. Okay? So when the sun casts a shadow, is it important to get your measurements done in a reasonable amount of time?
Yes.
Yes. Could you come out in the morning before first period and get the measurement, one measurement, and then realize, oh my gosh, I got to get to class, and then come back after lunch and do your other measurement?
Oh no, because the sun moves.
Yes, the sun moves, and at different parts of the day, your shadow, the length of your shadow is going to change. It's gonna change direction, and it's gonna change lengths. Okay? So if you're doing this sort of indirect measurement, your measurements need to be taken within a reasonable amount of time of each other. I mean, like 5 or 10 minutes would be a reasonable amount of time, but 8 hours, not a reasonable amount of time. Okay? Because that would too dramatically change your measurements, and then it wouldn't work very well. Okay, so let's just say we're going to put an X over here because that's the height we want to get, because we can't get a ladder because maybe it's against the school rules. You can't have a ladder on campus. I don't know. I'm pretty sure that's a rule. I don't think they write it in the rules, but I'm pretty sure it's a rule. Okay, and you probably can't climb it because that would go against the insurance policy and somebody would get hurt. Okay, so we're not going to climb it. So we're just going to measure that shadow. It's going to be 38 feet 4 inches. Okay? Is there anybody in here who's 5 feet 9 inches? Okay, we'll use Emilio. Here's Emilio. He's got a little wavy hair up top. Okay?
Oh, yeah.
And he's roughly 5 feet 9 inches. I think that looks very similar.
Oh.
Oh, you're not blue?
All
right. His shadow is 7 feet 8 inches. All right. So we've got 3 known measurements and 1 unknown measurement. That's pretty much what we need to set up a proportion, right? Okay. But before we can do it, we need to have our units all the same, right? Notice we have some feet and some inches, some feet and some inches, some feet and some inches. So how do you change 1 foot into inches? How many inches would that be?
12.
Right? You got 1 ruler, it's 12 inches, it's a foot. Okay? So we're going to take the shadow of the flagpole, which is 38, multiply it by the 12 inches. You can do this on your calculator. You should get 456. Add this 4 more inches. And so it's 460 inches. That's the shadow. I'm going to write it up here. Okay. Now let's get Emilio's height all completely in inches. So we're going to take the 5 feet, multiply it by 12, which gets us 60. Add the 9 more inches. He is 69 inches tall. Now let's get his shadow. So we're going to take the 7 and multiply it by 12. That gets us 84 inches plus the 8 more. So 92 inches. All right? So if you have a problem set up like this where they have a diagram on your left and a diagram on your right and a top number and a bottom number and a top number and a bottom number, it will fit into your proportion perfectly. So you're going to draw your fraction bar equal to your fraction bar. Keep your left on the left. Keep your right on the right. Keep your top in the numerator, your bottom in the denominator, your top in the numerator, your bottom in the denominator. Are there other ways to set it up? Yes. Will it work out for you? Yes. But if you can keep it simple and straight like that, then keep it as simple as you can. So we're going to go x to 460, 69 to 92. And then from there, it's just calculator work, right? You're going to do your cross product. So we're going to go x times 92, set that equal to 460 times 69. So we have 92x. I got 31,740. So you definitely want a calculator on that one. Divide both sides by 92. So x is 345. So that flagpole is 345 inches tall. But now we need to get it back to feet and inches, right? Because these were all given in feet and inches, feet and inches. So we're going to divide by 12. And that is 28 feet with 9 left over. So it's 28 feet and 9 inches. And your calculator will do all of that for you. Okay. Now let's talk about proportional perimeters and areas. Okay. To get proportional perimeters and areas, you're going to be given 2 figures. Okay, and the figures are going to give you some side measurements. And then one of the figures is probably going to have a perimeter and an area, and then you're going to have to figure out the perimeter and the area of the second one. So there's a ratio for each of them. The sides are going to be in the ratio of A to B. The first one to the second one, A to B. Perimeter is going to be the same way, A to B. The areas, however, are going to be A squared to B squared, because when you're finding the area of any polygon, you're actually finding how many squares are inside of it, right? So you're squaring, right? So let's look at an example. We're going to use 2 triangles, but I think the one on your assignment is rectangles, but it's going to be worked the same way. You're going to have 2 triangles. We'll call the first one LMN. We'll call the second one QRS. And let's get some measurements. One of the sides on the first triangle is 13 centimeters. And one of the sides on the second triangle is 9.1 centimeters. The perimeter of the first triangle is 36 centimeters. And the area is 60 centimeters squared. So that's what we want to find on this second triangle. We want to get the perimeter and we want to get the area. So we're going to set up a proportion for each of them, do the cross product, and then figure out the perimeter and then figure out the area. So let's do the perimeter first. Perimeters are going to have the same ratio. Okay? So if the ratio of the sides of the first and second triangle are 13 and 9.1, that's going to be my first ratio on the left. The ratio of the perimeters is going to be the same. So this one is 36. This one we don't know. That's where we'll put our X. Okay. Once you have that proportion set up, then you just do your cross product and solve. So 13 times X is 13X. 9.1 times 36. I can't do that in my head, so I punched my calculator. I got 327.6. Divide both sides by 13. So X, or the perimeter of the second triangle, is 25.2 centimeters. All right, I'm going to move this up, and you'll see it in just a second because we still need to do area. Okay, so that's perimeter. Any question on perimeter? You don't do anything weird with perimeters. You just set it up in your proportion, do your cross product, and solve. All right, area. Area, you're going to take the sides of the two polygons, in this case triangles, and you're going to square them. So you've got this one is 13 and this one is 9.1. You're going to take each of those and square them. That's going to be equal to the ratio of the areas. This one we know, it's 60. This one we don't know. We'll call it X or Y, whatever variable you like. Okay? Your calculator should have a squaring button. Or you can just type in 9.1 times 9.1. Or you can type 9.1 to the second power. If you don't know how to do that on your calculator, ask me and I'll show you where it's at. Okay? So now let's do the cross product. We've got 13 squared, which is 169, over 9.1 squared, which is 82.81. And then we go cross product. Let me zoom out a little bit. Okay, so 169x equals 60 times 82.81. Large numbers with decimals and stuff, so definitely use your calculator. I got 4,968.6. Divide both sides by the 169. That means that the area of the second triangle is going to be 29.4 centimeters squared. I'll move that up a little. Make it a little bit here. All right, finish copying that down.